Good morning students, how are you? Hope you are all in the pink of health. I am Atun Rai and you are watching bond making and bond breaking channel. So today I am going to discuss with you on 10 important questions. Yes, 10 important questions that is very important for the board exam as well as NEET and JEE. So keep patience and watch this video. Do not skip. Okay, let's go. So the first problem. So the first problem which is given, the first problem is, open your copy and write with me. Okay, first question, write the first question. First question is compare. First question is compare the acidity. Compare the acidity between alcohol and carboxylic acid. The first question is compare the acidity between alcohol and carboxylic acid. So according to the problem, firstly I take alcohol, that is ROH, and secondly I take any carboxylic acid, that is RC double bond OH. Okay, so if we compare this, the electron density of this oxygen and the electron density of this carbon. So when it releases H plus, it gives you RO minus and it gives you RC double bond O minus. Okay, this is the problem. So look, if it gives it minus here and the pi bond is broken, so resonance is starting. You get resonating structures. Okay, resonance is going on. So here the resonance is going on. But here not. So which is more acidic? So the more acidic is that it is the more acidic compound, because the tendency to release this OH minus is higher compared than it. What I said? The tendency to donate H plus is higher compared than this, because it puts the electron on the oxygen, so the density of electron on oxygen is increasing. For pulling the electron on the oxygen, the electron density on oxygen is increasing. For that reason, it does not want to release H plus, or it does not want to give H plus compared than this. So for the resonance, it is easy to donate H plus for this compound. So this is more acidic compared than this. Okay, so the answer is due to the resonance and inductive effect. Okay, so the key point of this answer is resonance and inductive effect. For the plus I effect, it does not show more acidic compared than carboxylic acids, and for resonance it shows more acidic compared than alcohol. Okay. Now the second problem. Now the second problem. Now the second problem is compare the acidity between carboxylic acid and phenol. So I remove this alcohol and write here phenol. Now the problem is compare the acidity between phenol and carboxylic acid. So you know that it is phenol, and this is carboxylic acid. So the problem is which gives you more acidic. So more acidic is that if you start its oxalate ion, that is RCOO minus. So it gives you the product, it donates this and the pi bond is broken. So the product is RCO minus and double bond. So the participation of those 1 and 2 resonating structure is more. Okay, both participation percentage is maximum. Okay, but on the phenoxide ion, that is O minus, it gives you the electron here, so minus is here. So the percentage of participation is of this compound is maximum, but its resonating structures, that is minus, partially double bond, it shows positive charge, and then it's going on. So it is going on. So those the resonating structure which you will get for the resonance, the participation is not maximum. The participation of this compound is maximum, but the other resonating structures or structures are not participate as like this. But there is 2 resonating structures, but both 2 participation is maximum. As the participation is maximum, it shows you acidic, more acidic compared to this. Now the third question. Third question is CH3COOH, acidic acid. Then you take CH3CH2COOH, propionic acid. Then you take CH3 COOH, third compound, and the fourth one is CH3 COOH. Those are the 4 compounds. You write the order of acidic. Write the acidic order. So this is the first compound, this is second compound, this is third compound, and this is fourth compound. Which shows you more acidic? Look, it gives you, there is the number of bulky group is 3. the number of bulky group is 3. So the power of pulling electron on the carbon or the oxygen, the electron density is increasing. So due to the presence of CH3, the density of electron is increasing, and as the density of electron is increasing, it is not easy to release hydrogen plus. What I say, as the bulky group pulls the electron on the oxygen, as the number of bulky group 3, so the power of pulling electron on the oxygen is high. Okay, so the electron density on the oxygen, is increasing. As the electron density on oxygen is increasing, so as the electron density on oxygen is increasing, so it is not easy to release H plus, because the electron negativity on oxygen is high, so it wants to attack the positive ion, that is H plus. It wants to attack the H plus ion, so it is not easy to release H plus from this compound, so it never shows, or it never wants to form acidic nature. So due to the presence of more plus I effect compounds, the pulling power of electron on oxygen is increasing. As the pulling power of electron on oxygen is increasing, for that reason it is not easy to release the H plus. On the other hand, the number of CH3 is less than on that fourth compound. So the power of pulling electron is less than this compound. So the electron density on oxygen is less than that compound. So the attraction between O and H is less than fourth compound. So it is easy to release H plus compared than 4. But it is not easy, because 2 bulky group is here, so pulling the electron on the oxygen is increasing, so therefore this bond the oxygen cannot want to release H plus. So compared than 4 it is easier compared than 4, but it is not easier compared than 2, because there is one bulky group. So it pulls the electron, so the electron density increasing, but it is not more compared than 3, so it shows more acidic compared than 3. And finally the bulky group is C2H5, but there the bulky group is CH3, so the power of pulling electron on the oxygen is less compared than 2, 3 and 4. So number 1 shows more acidic. So the key point, you can write it, key point, write with me. Key point: number of plus I affected group, increasing tendency, increasing electron density on on electronegative element, electron density on electronegative element increasing, tendency to donate H plus decreasing, so acidic nature decreasing. Number of plus I affected group increasing, as like this: number of I affected group 1, number of I affected group 2, number of I affected group 3. So number of I affected group increasing, electron density increasing, electron density on electronegative element increasing, so electron density on this group increasing, electron density on this group increasing, electron density on this group increasing. So the increasing of electron density is high, tendency to donate H plus decreasing. So compare than this, the tendency to release this H plus is decreasing, so it does not want to show acidic nature, because tendency to donate H plus decreasing, so the acidic nature is decreasing. Understand? Very easy method. Okay, now take another example. Now take another example, that is example number 4. Example number 4. If you have FCH2COOH, or you have ClCH2COOH, or you have BrCH2COOH, or you have ICH2COOH, and compare the acidic order. Compare the acidic order, or write the appropriate acidic order. So this is the number 1 compound, this is number 2 compound, and this is number 3, as well as this is number 4. Look, the electronegative element of this compound, if we compare the fluorine, chlorine, bromine, iodine, electronegativity down the group, electronegativity decreasing. So the electronegativity of fluorine is higher compared than others. Electronegativity, as the electronegativity of fluorine is higher, so the tendency of this fluorine is to pull the electron. So the electron density on oxygen or electronegative element is higher. So the tendency to pull the electron towards it of fluorine is higher compared than chlorine, bromine, iodine. So iodine shows you the pulling power. The pulling power of electron is higher. So pulling power of electron is lower. So as the pulling power of electron is lower, so the electron density, the tendency, the decreasing of electron density on oxygen is lower. So the bond between O and H not much weaker than this compound. So you can write this: if the electronegative element, if the electronegative element is stronger, electronegative element, fluorine is more stronger. So electronegativity if stronger, so density of electron decreases. So bond between O and H, OH bond weaker, so tendency to donate H plus is, as the electronegativity of fluorine is higher than chlorine, bromine, and iodine, it shows more acidic nature. So the correct order is 1, 2, 3, more acidic compared than others. This is the 4th question. Now take the 5th question. Now take the 5th question. Cl CH2COOH, then Cl CHCOO H. Thirdly, Cl, 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 C, COOH. I take this three compound. So acidic order. So the correct acidic order. I hope you can give this answer. So the number of electronegative element is higher. Here the number of electronegative element 2. Here the number of electronegative element 1. Here the number of electronegative element 3. So the pulling power. This is the bond O and H. So the pulling power of electron. So the pulling power of electron is higher than others. So electron density on electronegative element decreasing. So the bond between them decreasing. So it is easy to release H plus. So it shows you higher acidic. So what I say? Key point. What is the key point? Number of electronegative element increasing, electron density decreasing, electron density on this group decreasing, easy to donate H plus, that is also increasing. So acidic nature increasing, so it shows you more acidic character. So the correct order is, this is more acidic compared to this, because the number of chlorine is higher and it shows you more acidic as the number of electronegative element is high. So this is the fifth question. Now the sixth question. Sixth question is that HC triple bond C COOH, first compound. Second, H2C double bond CH COOH, and third one CH3 CH2 COOH. CH3 CH2, I can write in this way, CH3 CH2 COOH. So write the acidic order. So let's see, the hybridization of this carbon is sp, and the hybridization of this compound is sp2, as the double bond is here, and the hybridization of this compound is sp3. Okay. So find out the percentage of S and P compound. For Sp, the percentage of S 50%. For Sp2, the percentage of this carbon near about 33%. Okay, and the percentage of this compound 25%. Okay, so more S character, more equal to more acidic, more S character. So as it shows, Sp hybridized or Sp hybridization, the S character is 50%, that is maximum. So that's why it gives you, it is more acidic compared than others. Okay. Now take the next problem, number 7. Number 7. Okay. So the number 7, the problem is find out which, okay, wait for a minute, find out which is which is necessary, okay. Then HCOOH A. On formic acid you used A and you get CH3OH, and then you take B and the product is CH3I. Then you take C and the product is CH3CN. Then the product is D and you get CH3COOH. This is the problem. So firstly formic acid, and then acetic acid, then methyl iodide, methyl cyanide, and then acetic acid. So this is the formation from the formic acid to acetic acid. Okay. So find out the reagent. The first reagent is, for this reason you should use a reducing agent, a strong reducing agent. So the first A is lithium aluminium hydride. This is the first. And the second is you should put I on OH. So you must use Ki or you use red P and iodine. So the B is red P and I2. And third is Caesian. This is first lithium aluminum hydride, strong reducing agent, then red P and I2, then Caesian, and after Caesian you must use dilute H2SO4 and reflux. This is the seventh method or seventh number question, how to convert from formic acid to acetic acid. This is very, very important. Now the question number 8. Okay, question number 8. If you have benzoic acid, and obviously you have benzoic acid and obviously you have phenol. Benzoic acid and you have phenol. So this is benzoic acid and this is phenol. Write a chemically difference reaction. If you use FeCl3, no color is formed. But if you use on phenol FeCl3, violet color is formed. So this is very important. On benzoic acid, FeCl3 does not give any color, but on phenol FeCl3 gets violet. Okay. Now take another. If you have oxalic acid and acetic acid, what I say? Oxalic acid and acetic acid. Oxalic acid and acetic acid. Oxalic acid COOH and COOH, and acetic acid CH3COOH. Oxalic acid and acetic acid. So what is the difference chemical reaction? If you use CaCl2, calcium chloride, CaCl2, white PPT you observed. Okay, white PPT you observed, and there if it react with CaCl2, no PPT is occurred, no precipitate is occurred. This is very important. Okay, and the question number 9. Another question number 9. If you want, if you want to convert, question number 9, you want to convert benzoic acid, okay, just wait. You want to convert benzoic acid to metabromoaniline. Benzoic acid. So this is benzoic acid. Then you use Br2 and Fe Br3. So you get one Br on the meta position. So COH and the meta position gets Br. Okay, metabromoacetic acid. Then you use SOCl2. So you get, so the product is COCl and Br. Then you use NH3. NH3 gives you HCl, so CONH2 and Br. Then you use Br2 and KOH, alcoholic KOH, and heat. So CO is removed from here, aniline and bromine. So this is the number 9th number question, and very important. Benzoic acid to metabromoaniline. If you have benzoic acid, you react with Br and FeBr3. So Br on the meta position. Then you use SOCl2. SOCl2 means COCl. Then you use ammonia and you get CONH2. Then you use Br2 and alcoholic KOH and heat, and you get this product metabromoaniline. Okay. So last question is what are the products? Question number 10. What are the products? If you have CH3COOH, light is very disturbing today. So then you use CaOH2. What will be the product? This is CH3COOCa. This is whole. This will be the product. The first question, what will be the product? This is the product. Then if you distill heat, then you take heat. What will be the product? CH3COO, CH3COO, and this is Ca. So CaCO3 is removed. CaCO3 is removed. So minus CaCO3, you can form ketone. So acetic acid to ketone you can prepare. So this is also an important question, how you convert acetic acid to ketone. Okay, hope you understand. Today light is disturbing so much, so I don't want to make it longer because light is disturbing, and you know that I take 2 shots due to the bad light. My dress is proof that. So thank you so much. Wait for next video. Thank you so much. Bye.